Okay, class, we're going to talk about lesson 7.2 today, which builds off of lesson 7.1. Lesson 7.1 was about solving two-step equations, and there's going to be two steps in these equations also, except that we'll have to simplify first on one side. In other words, we might have more than one x term, more than one variable term on one side. Look at this model. You've got two x's, 7 positive ones, and another x. And so we have 2x plus 7 plus 1x. Well, before solving for x, it makes sense to combine all of these x terms and make this 3x plus 7 before we solve it. And that's what this is all about. We have 2x, 1x, and we can add those together because they are alike. What are like terms? Hunter?
Like variables that are the same, like 3x and 96x.
Yes, 3x and 96x, 99x. Those are 99 x's. But can you add 3x and 7? Can you add these two?
No.
Why not?
These are not like terms.
Because they're not like terms. Because this isn't 3x and 7x. This is just 3x and 7. 7 ones. They have, the variable terms have to be exactly alike in order for you to add them. Okay? Now, when we are talking about, in this lesson, we're going to learn about equations, for example, that represent numbers that add up to a certain amount. This is example 2 in your book. In example 2, we're going to find consecutive integers. In other words, consecutive whole numbers that add up to a certain number. It says, let n be the first number in a series of numbers. If they're consecutive, they're right next to each other, then n plus 1 is the next number, isn't it? And n plus 2 is the number after that. Think about these numbers, 3, 4, and 5. If 3 is the first number, then 3 plus 1 equals 4, and 3 plus 2 equals 5. So we can use these expressions, n plus 1, n plus 2, to be the expressions for consecutive integers. Okay? Think about it. If this was the model for consecutive integers, this would be n, and n plus 1, and n plus 2. How many n's are there then? Are there then? N, and n. There are 3 n's. And how many 1's are there? 3. See, you can see them. N, 1, 2, and 3. So we can simplify this whole expression as 3n plus 3. Does everybody see that? 3n plus 3 is then the expression for 3 consecutive integers. Okay? Now, let's say that it says those 3 consecutive integers add up to the number 96. Well, then we can write this expression, 3n plus 3 equals 96. We know that it equals 96 if we add them all together. And then you can prove it by solving for n. Okay? How would we solve for n? How would we solve this for n? Joey?
I'm doing a two-step equation problem.
Right. We'd add -3 to each side. So 3n would equal 90. No, we added 3n, or added -3 to each side. So over here, I'll solve it for you. 3n plus 3 equals 96. If we add -3, what's 96 plus -3? Class? 93. And that equals 0 plus 3n. So 3n equals 93. Divide by 3, and n equals 31, doesn't it? So that n represents the first of 3 integers. Hunter?
Yeah, so you can probably just do that in your head. Just take 3 away from 96 and then divide 93 by 3.
Yeah, to be honest, you could probably do most of these equations in your head, but it doesn't prove anything. All right? That's not proving that your answer, those are the 3 integers. You can come up with those 3 integers, okay? But you're not learning how to solve an equation then. So, what we're talking about is learning how to solve and combine like terms and then solve an equation. And we're using this problem as an example of how to do that. Okay? Look at example 1 in your book. Here's an example that you will use. It says Jake and Suki collect model airplanes. Suki has 4 fewer than twice as many as Jake. So together they have 14 models. Solve this equation. So, Jake and Suki, and it says Suki has 4 fewer than twice as many. Now, we don't know how many models each one has, do we? Well, let's make m our variable for models. It says they have 14 altogether, right? So, Suki has 4 less than twice as many as Jake. So if Jake has m models, then Suki has 2m minus 4. 4 less than twice as many. Okay? Does that make sense? 2 times m, but 4 less than that. Now, how would we find how many they have? If it says that between the 2 of them, they have 14. The sum is 14, right? So, Joey? Okay, use the model. The model can help us then, or this is a type of model, okay? And that can help us to write this equation. Troy.
Do what we were always doing. So you add -4 to 4.
Okay, wait. We're going to write an equation first.
Oh, okay.
All right? So, Jake's models, m, plus Suki's models, 2m plus, or minus 4, equals, what? 14. Now, what can we do? combine like terms. 3m minus 4 equals 14. Then what?
Then you add
Come on.
negative 4.
Add 4 both sides. Divide by 3.
You get
And m equals 6. So who has 6? Dylan? Jake has 6. And how many does Suki have? 2 times 6 is 12, minus 4 is 8. Yep. Yes? That's not going to help you learn how to solve an equation. Alright? Again, you might be able to get it by guessing and checking, but that's not going to help you to solve an equation. Alright? Yeah?
If it says in the problem, Suki has 4 fewer than twice as many, or like the 4 fewer part, doesn't that mean that Suki has less than Jake?
Yeah,
No, but it says he has 4 fewer than
double.
twice as many.
Oh, wait,
So 12.
yes.
So 2m,
8 minus 4
but minus 4.
is 4.
Okay?
4 less than double.
Alright, your assignment is 2 through 8 on page 359. 2 through 8 in the